So today we are going to discuss about another protocol, that is Goback N Protocol. Okay, so in transport layer, as I told you, the TCP, if I try to understand, okay, fine, it makes use of like many protocols, right? So it may not be TCP. I'm talking about the transport layer. So Goback N Protocol is one such protocol in order to improve the efficiency of the transmission, right? Because in case, what was a drawback that we try to see in case of stop and wait protocol? In case of stop and wait, okay, I used to send one packet. The receiver will receive one packet, and he has to acknowledge the packet. Until then, the second packet will be not. I mean, it will not be sent, right? So it has to be. The sender and the receiver both has to wait, right? So in order to improve this transmission efficiency, okay, that means to fill the pipelining concept, because pipelining is one such concept which was lagging in stop and wait. Okay, multiple packets are required to be like transmitted from sender to the receiver without even waiting for an acknowledgement. Okay, so other words, what we are telling is we need like more number of packets to be sent. Okay, so that I can keep the channel busy. Okay, so one second. Fine. So in order to keep the channel busy, one after the other, the packets are sent, and the sender will be waiting for the acknowledgement for all the protocol, all the packets which is sent from the sender to receiver. Okay. So this is called as like Goback N protocol. What is Goback N? I'll tell you in the further concept. Okay. Basically, the go back in case of go back in protocol, we can send several packets, okay, before receiving the acknowledgements for all, right? So here, though that sender can send, okay, see, this is the sender window, okay, right? I have fixed the sender window size is like 0 to 7 if I call, okay, like starting SF, okay, and let me fix up the size is like 0 to n minus 1, right? Okay, so in that situation, so sender can send the as per the window size all the packets, okay, but in case of go back in protocol, the receiver is having the capacity. That means the receiver can only buffer one packet. Any number of packets that is as per the window size, the sender may send, okay, but he will acknowledge or he will receive only one packet, and he will acknowledge that particular packet to the sender, okay, and he will receive the next packet sent from the sender. Okay, that means when a sender sends a packets, that I mean, say for example 7 packets only I'll consider, okay, that is 0 1 2 3 4 5 6 7, okay. So let me take up the window size. I have fixed I mean, there might be n number of packets. I'll just fix the window size is this much, okay. Say that sender has sent like first interval of time, he has sent 0 continuously after the, I mean, 1 2 3 he might have sent, okay, but initially receiver will receive only first packet, that is 0, okay. So till then, the sender has to keep all the packets in its buffer. That means he has to keep a copy of whatever the packets he has sent, that is a sender has sent, until he receives the acknowledgement for all the packets whatever he has sent. Okay, so here, especially in this picture, you can see that uh, some of the concepts also we'll discuss here. See, each packet, we know that it has been carried with an some information, right? Checksum, acknowledgement number, synchronization number, all these things will be there. And in the acknowledgement, and here also you can see acknowledgement number is added, but in case of stop and wait protocol, acknowledgement number was replaced by a sequence number, right? Here also sequence number will be there. I don't know why they have not shown sequence number, because sequence number is required for each and every packet. Acknowledgement is provided with acknowledgement number and the checksum. Okay, so as we have mentioned like before, in case of stop and wait protocol, here also the sequence numbers are modulo m, so it is 2 raised to m, where m you can consider as the size of the sequence number. Okay, m is considered to be the size of the sequence number in that particular header field. Okay, of in bits, if we consider it is to be the 32 bits. If you remember, in the header we had kept 32-bit spacing for the sequence number, right? And with respect to acknowledgement number, in this case, um, acknowledgement number is like cumulative. Okay, so and also it defines the sequence number of the next packet which is expected by the receiver. Okay, that means if a sender is going to send x number of x the packet, okay, x number of packet, then he will acknowledge with x plus 1. That means he is sending the acknowledgement that what he is expecting the next packet. Okay, say for example, if I tell x in place of x, if I tell that is packet number 7, okay, then he will acknowledge with 8. That means he has received 7 packets. Okay, you send me 8th packet, like that he will acknowledge. Okay, so in Goback N protocol, the acknowledgement number is cumulative and it defines the sequence number of the next packet which is expected, or which is expected to arrive at the receiver end. Now we'll see the windows. How does basically receiver and the sender window work? Okay, so this is the send window for Goback N. You can see that there are 4 segments here, right? See, first segment, second, third, fourth, right? And here the send window, whatever we are considering, okay, the send window, it's abstract. Okay, that means it is an imaginary box, right? The send window, what we are talking, it is an imaginary box which basically covers the sequence numbers. Okay, which covers the sequence numbers of data packets. Okay, say for example, I want to send some here 0 to 6, that is 7 packets I want to send. Okay, so your window we are talking, it's nothing but it's an imaginary box, okay, which is going to carry the numbering, that is a sequence number of the data packets, which can like that has to be in the transit, or that can be sent. Okay, now in each window position, right, some of these sequence numbers defines the packets that has to be sent. Okay, and some defines that it can be sent, right? That means here you can see outstanding sent but not acknowledged. Okay, so in the next segment you can see can be sent when accepted from the process. That means what we are trying to tell is the window position, in each window position, okay, a few are considered for a case where the packets that have already been sent, okay, and you're waiting for the acknowledgement. Okay, and other packets, like still your these, I mean, still you are waiting for this acknowledgement. Okay, and these also, in case if there is a vacancy or the application or the process is expecting, then the possibility is that you can also send this, but not sent. Okay, this is sent waiting for the acknowledgement. Fine. So that means you have not filled up all the sequence number of the data packets. That means all the packets are not sent of the respective window, right? Though I have considered the window size is this much, okay, total window size starting from 0 to 6. Okay, I may not send all the packets, right? That means you are making in the form of a small segments, right? So here, as I told you, we have 4 segments here, right? What about the first segment? The first segment is, it is the first region. Here it tells that that means your now this is a window left of your window, right? So the left of your window, it defines basically the sequence numbers that belongs to the particular packet, okay, which are sent and already they are acknowledged and purged. Okay, purged is once you have received an acknowledgement, the sender will remove the packet or get rid of that particular packet. That means he'll delete it from its buffer. Okay, because earlier he might have saved it, right? Till he receives the acknowledgement. So once he receives the acknowledgement, he'll purge it. Okay. Then the second region, what we are talking here, this is the first outstanding and the next to send. As I was telling, like some of the packets you might have sent it and waiting for the acknowledgement. And since you are waiting for the acknowledgement for these things, I mean, the remaining 4, 5, 6 are in queue. Okay, that means they can be sent as per the process request from the process. That is a third range. Okay, so finally we have the fourth range, that is what you can say. It basically defines the range of sequence number for the specific packets that can be sent. Okay, that means the corresponding what you can say, if I talk about the application layer, and this is the transport layer. Okay, so here we are trying to tell that the sender window, and this is a information which is going to the receiver, right? See, what happens is, now whatever the information that is being taken from the application layer to the transport layer, okay, that we have framed a segment and we have fixed up a window size. Okay, now what is happening is the information which is sent from the transport layer, at the receiver end, the transport layer will receive the packets. Okay, now a few number of packets are like sent to the application layer. Okay, but there are some packets which cannot be accepted from the process, right? That means still the buffer is completely like now filled, or it cannot accept the number of packets. Okay, so I was telling about the packets cannot be accepted from the process, because still the application layer or the process in an application layer is busy taking the earlier packets which is sent. That means your window itself is like not completed. So where is the sliding happening, right? It cannot move it to the next frame or the next packet. Okay, so definitely whatever is there within your window has to be completed, and the window should slide to the next packet. Till then it cannot be processed, or it cannot be sent to the application layer. Like that, I mean, in case of sender window, the same process happens. That means it cannot accept it from the application layer, right? It cannot be processed. And here, yeah, some of the letters that I could see here: SF, SN, S size, right? So basically we know window itself is an abstraction. correct? It is an imaginary box. Okay. Now we have defined something called as three variables here, right? What are those? SF is nothing but it is a send window. Okay. First outstanding. The first outstanding packet. Okay. That means that's the beginning of your window packet, right? Then we have something called as SN. SN is also, it belongs to the send window. Okay. It is a next packet which has to be sent. Okay, you can see next to send. Then we have something called as S size. Okay, S size is the total window size, and that is again, feel free that you can fix up the window size as per the your channel capacity. Okay. Now, um, when I talk about the send window, okay, you can see the next sliding here. See, as I was telling, what is the maximum size of the window or the sequence number that you can give? It is 0 to 2 power m minus 1, right? Right. So we have defined the three variables like SF, SN, and S size in case of Goback N protocol. That is for our understanding again. Okay. Say that initially I have sent 0, 1, 2, 3. Okay. For which all the four are being like sent. Okay. And they are acknowledged to the left of the window. Fine. Now the SF is going to indicate when the window slides over to the next packet. Okay, so that becomes the beginning of your window where SF is giving you a sequence number of the first oldest outstanding packet. That means when it slides over, no, when the window is getting slide over to the next packet, it will give the sequence number of the oldest outstanding. I mean, already it was in a queue. Fourth packet is already, it was in a queue, but it was not acknowledged, right? Okay, but when the slide moves, that becomes the first oldest packet. Okay, the preference is given to the sequence number, which is a oldest outstanding packet. Okay, so that is what is FS. How, I mean, it's been defined. And here SN, it also holds the sequence number that will be assigned to the next packet, which is to be like sent. Now this is window before sliding. Now say that I have received the acknowledgement for 4 and 5. Now what happens? Once you get the acknowledgement for 4 and 5, the window slides over. Okay, it moves to the next packet. Okay, so the SF is now pointing to what? 6 and 7. That means the priority or preference is given to the oldest outstanding. That means 6 and 7 is already in the queue, right? Okay, they are already sent and waiting for the acknowledgement. Then it will add for the next packets which is to be sent. So window, when it slides over, it adds on the further packets who are in queue. Okay. Any doubt? Now let us talk about the receive window. Fine. So at the receiver window, what we know that any number of packets you send from the sender as per your window size. Okay, receiver will make sure that he receives, his buffer capacity is like only one. Okay, so only one packet with a sequence number which is matching to the respective value of R. Okay, it will be accepted and acknowledged. Keep in mind. Okay, so say that sender has sent in an order like 0, 1, 2, 3, 4, 5, like that. Like 0 is first received, he will acknowledge. 1 is received, I'll acknowledge. So already received and acknowledged packets are there here. Next time he may receive the 5th packet. Okay, and still 6, 7 will be like sent already by the sender, but your receiver will receive the fifth packet, okay, because the size, the receiver window size is what, always 1 for Goback N. Okay, so keep in mind, in Goback N, protocol, receiver size, receiver window size is always 1. Okay, and the receiver window, he'll make sure that the correct data packets are received and that packet is to be acknowledged. Okay, now here what happens, in this case, that is receive window, we need only one variable, that is RN is sufficient. But with respect to the sender window, we saw that we had three variables, correct? One is SF, SN, S size, right? Okay, so here I could see only one variable RN, and R size is equal to 1, it is fixed. Okay, and here only RN is a receive window where it is going to acknowledge with the next packet which is to be expected. Okay, so RN itself defines the abstraction, right? Okay, or the imaginary box. And here say for example, when the correct packet is received, okay, that means, see, when even though I send in an order 0 1 2 3 4 5, possibility that I may not receive, sometimes, see, I am expecting 0, right? Or after 0 I may expect 1. Okay, let me take up the current situation where 5 is in the expected list, right? Now think that 5 is expected, but unfortunately 6 has arrived. Okay, where sender has sent even 6 also, right? So in that situation, what happens? The receiver will immediately discard it. Okay, that means he will be waiting for the correct sequence number. Hope you are understanding. Okay, because he has acknowledged with the next packet, that is X plus 1th packet he is expecting, but he is getting X plus 2 packet, right? Which is of not, I mean, he does not require that in at that particular instant. Okay, so since he is not received this particular packet X plus 1, what he was expecting, the receiver was expecting, okay, receiver immediately he has an option to discard it, right? Okay, so whenever he receives the correct one, then the window will slide to Rn plus 1. Okay, and again this is also like modulo 2 power m sequence number is provided even at the receiver window. Okay, and again here the imaginary box what we are talking is a window size itself, and it is a 1, and whenever the correct packet is received, the sliding will occur one slot at a time. Okay, that means he will not take up all other packets into consideration. He'll just move by one slot. That's it. Any doubt? Now let us talk about the timer concept in Goback N Protocol. See, already we know whenever a sender sends a packet, okay, to the receiver, he will start the timer, right? He'll start the timer immediately as the packet is sent. Okay, now as I told you that the sender is having the capacity now to send some number of packets, but receiver is having the capacity to receive only one at a time. Okay, now think that many packets are like in a queue now, they are all sent. Okay, some 4 to 5 packets are in a queue, right? Now, how the timer will be, I mean, do you think, because each packet here needs a timer, agree? That means a timer for each packet is to be like set, or whenever it is sent, no timer has to be activated. Agree? Yes or no? Hope you understood my question. ನಾನೇನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ, ನನ್ನ ಸೆಂಡರಲ್ಲಿ ಒಂದು 5-6 ಪ್ಯಾಕೆಟ್ ಕಳಿಸಿರ್ತೀನಿ, ಆಯಿತಾ? ರಿಸೀವರಲ್ಲಿ ಒಂದೇ ಪ್ಯಾಕೆಟ್ ರಿಸೀವ್ ಆಗೋದು. ಬಟ್ ಈವನ್ ಒಂದು ಪ್ಯಾಕೆಟ್ ಕಳಿಸಿದ್ರು ನನ್ನ ಟೈಮರ್ ಸ್ಟಾರ್ಟ್ ಆಗಬೇಕಿಲ್ಲಿ, ಕರೆಕ್ಟಾ? ಈಗ ನಾನು ಅದೇ ಥರ 4-5 ಪ್ಯಾಕೆಟ್ನ ಕಳಿಸಿರ್ತೀನಿ ಅಲ್ವಾ? ಎಲ್ಲ ಪ್ಯಾಕೆಟ್ಗೂ ಟೈಮರ್ ಸ್ಟಾರ್ಟ್ ಆಗಬೇಕಲ್ವಾ? ಅಂದರೆ ನನ್ನ ಹತ್ರ ಅಷ್ಟು ಟೈಮರ್ಸ್ ಬೇಕಾ? ಕ್ವಶನ್. You think that I require the same number of timers, that how many packets that I'm going to send? No. I require the same timer, the only one timer what the sender was using. Okay, because in this protocol, in Goback N Protocol, we use only one timer, and the reason is that, see, the reason why we are taking only one timer is, see, what happens is first packet you will send. Okay, the timer for the first outstanding packet always expires first, correct? Yes, when the timer for the first packet is expired, immediately the second packet timer will be started. Okay, so in that way, what happens, timer gets shifted to packet. Okay, though you have sent it in though all the outstanding packets are sent. Okay, so when this timer expires, what happens, if at all the acknowledgements are received, it's well and good. The sender will delete the packets whatever it is sent. Okay, in case, see, one more condition here you need to remember. In case in Goback N Protocol, I might have sent 4 packets, like 0, 1, 2, 3, 4, 4. Okay, 5 packets. Fine, I might have sent 5 packets. Think that I've received acknowledgement for only 0 but not for 4. That means 1, 2, 3, 4 I have not received. Okay, so if the timer expires, okay, in that case what happens is, sender will resend all the remaining n packets, that is 1, 2, 3, 4, to the receiver. Okay, so that is why it is go back n. Hope you are understanding. That means, say that when the timer expires, okay, sender has to resend all the outstanding packets which are not been acknowledged, right? Say, okay, I'll give an example. Let SF is equal to 3. Okay, so when SF is equal to 3, this means that, see, the packets earlier, like before to 3, that means what I can tell, 0, 1 and 2. Okay, all these are sent and acknowledged, correct? When I'm talking about SF is equal to 3, SF is what is SF here? What is SF in this sending window? Hello, am I audible? Yes, hello. ಕೇಳಿಸ್ತಾ ಇದೆಯೇನಪ್ಪ?
Yes, ma'am.
Then somebody at least talk, no? I feel that, otherwise I feel that, okay, is there any problem with my network or not? SF ಅಂದ್ರೆ ಏನು ಇಲ್ಲಿ ಸೆಂಡಿಂಗ್ ವಿಂಡೋದಲ್ಲಿ? SF ಅಂದ್ರೆ ಏನು? I told you there are 3 variables in the sending window. SF, SN, SI. What is SF here? see in this? What is SF here? Look at the diagram and tell me what is SF. Hope you people are listening. Yes. ಕೇಳಿಸ್ಕೊಂತಾ ಇದ್ದೀರಾ?
Yes, ma'am.
ಏನ್ರಿ ಒಬ್ರು ರೆಸ್ಪಾಂಡೇ ಮಾಡಲ್ಲ ಅಂತೀರಾ? SF ಅಂದ್ರೆ ಏನ್ರಿ?
First SIM.
It is a first outstanding packet who is waiting, who has already been sent and waiting for the acknowledgement. Correct, no? So ಇಲ್ಲಿ ರಿಸೀವರ್ ವಿಂಡೋದಲ್ಲಿ ಈಗ ನಾನು SF, let me take one more example. I'll tell SF is equal to 6. 6 means what it indicates? What it indicates? That means if I tell SF is equal to 6, it indicates that all the 0 to 5 packets are already been sent and acknowledged. Correct? Right? Okay, let me take SF is equal to 3. Okay, it means that 3, 4, 5, 6, blah blah. Fine. So these packets are still have not been acknowledged. Correct?
Yes, ma'am.
Hope you understood what I told here. If I tell SF is equal to 6, that means earlier packets 0 to 5 are acknowledged. If I say the 6, that means the remaining 6, 7, 8, 9, okay, they are not acknowledged. Correct? Okay, so when timeout occurs, okay, the machine goes back n locations and resends all the packets. Right? You understood?
Yes, ma'am.
Okay. So when it is resending, okay, there is also one more drawback here. When it resends the packets, okay, it goes back to the n location and resends all the packets. In that situation, there is a possibility that there may be a duplicate packets which is received by the receiver. Okay. See, try to understand the name, what we are trying to tell. Goback N. Here is the meaning where Goback N is we are talking. Okay. That means when you are all the outstanding n packets go, when the n locations are being like resent to the receiver, possibility that there may be duplicate packets are received by the receiver. Okay, that we'll see it. Fine. Now we can understand this Windows and other Goback N Protocol better way by using the finite state machines of the Goback N Protocol. Okay, so definitely we know we'll be writing the FSM for both sender sides and the receiver side. There will be, I mean, two concept analysis there at two different location. And initially we know that sender starts in the ready state. Okay, and till any event occurs, right, it will be in the ready state, and thereafter it can be in one of the state, that is either in the ready state. If any event occurs, no, it will be either in the ready state or in the blocking state. Right? So there are two states which we have shown here is the ready and the blocking state. Okay, and we have defined two variables that are normally initialized to 0. That is, what are the two variables? SF and SN is, it's in basically it is initialized to 0. at the initial condition. Okay. Now we'll see the ready state. Okay. So in ready state, there are like 1, 2, 3, yeah, 4 events. Okay. That occurs when the sender is in ready state. Okay. So it can occur 4 events. Fine. What is the first event? Say that if a request comes from the application layer. Okay. Say that I have a request from the application layer. Fine. Then sender, what he will do, he creates a packet with some sequence number. Correct. So he'll make a packet of sequence number. I'll name it as SN. Okay. And store a copy of that packet. Right. And after storing, you send those packets and immediately start the timer. Okay. If it is not running, if the timer is not running, you start the timer. Okay. And you increment SN to be SN plus 1 because you have sent SN. No. Now the sequence number has to be like incremented to SN plus 1. Your buffer should be like pointed or indicated to SN plus 1. Okay. Now that is the first condition. Whenever the request or the request comes from the application layer or the process, particular process. The second condition is if an error-free acknowledgement occurs. Okay. In that situation, like you have received an acknowledgement for a specific packet SN. Okay. And if an error-free acknowledgement occurs with the respective acknowledgement number, okay, that means SF is equal to acknowledgement number. The respective acknowledgement number is received. Okay, then what happens? The sender should slide the window. Okay, that means SF to be like it should be shifted to the acknowledgement number because acknowledgement or number always will be plus 1. Correct? No, so it will shift it to the next location. Hope you are understanding. Because acknowledgement number will be nothing but the next location, right? Whatever the receiver is expecting, that value. So he will update the sliding window to that particular location. So SF would be now acknowledgement number. And if acknowledgement number equals to SN, stop the timer. That means if whatever acknowledgement you have received for the previous one, it is correct. Okay. Then stop the timer. Okay. If at all it's not, then you have to restart the timer and resend the same packet. Right. That means if all the outstanding packets are not acknowledged, okay, then the timer is restarted. Right. So that is the second event which may occur in the ready state. Third condition, say that if a corrupted acknowledgement is received, okay, or an error-free acknowledgement with acknowledgement number outside window size, okay, some different acknowledgement number, okay. If at all wrong information is received, or you can say which is not expected information is received, in that situation, that particular packet will be discarded. Okay, so what it should do, it should discard the corrupted acknowledgement or acknowledgement number with an out of window. Okay, next fourth event is, say for example, I have sender has resent the all the outstanding packets, and some set of packets he has already sent. In case if the timeout occurs, okay, so in that situation, what the sender should do, he has to resend all the outstanding packets and restart the timer. Okay, so these are all the 4 events that may occur. Okay, the loopings we have shown here, you can see. Okay, what it has to do. So based on the condition, it is all the arrow marks are going to show what it has to do, right? So next is we have blocking state. See, either of the one of the state, it will be there, right? When an event occurs, either in the ready state or in the blocking state. Think that it is in the blocking state. Whenever it is in the block state or blocking state, 3 events can occur. Okay, 1, 2, 3. So what are those 3 events? If an error-free acknowledgement arrives, okay, with acknowledgement number related to one of the outstanding packet. Fine. In that situation, the sender, he has to slide the window, that is SF is equal to acknowledgement number. Okay, you can see here. Fine. So what happens is an error-free packet, if it is arriving, in case if a corrupted acknowledgement or an error-free acknowledgement with a different acknowledgement number or greater than or less than equal to SN is arrived, then the receiver sender should discard that particular acknowledgement packet which is received. Okay, so in case if a timeout occurs in the block state, okay, resend all the outstanding packets and restart the timer. Okay, and this is the condition where your window size is full. Okay, SN is equal to SF plus S size. Okay, so this condition where SF is like, say for example, initially you set it SF is equal to acknowledgement number, right? If all the outstanding packets are acknowledged, then acknowledgement number will be SN. That means SF is equal to acknowledgement number. In case if all the acknowledgement is received, okay, then acknowledgement number will be equal to SN. Okay, then in that situation you can stop the timer. Right? See, you should clearly know what is SF, what is SN, then you will understand it. Okay, so 3 events will occur here. Okay, so with respect to the blocking state, and you can see this, and with respect to the receiver, okay, receiver initially even this fellow will also be in the ready state. Okay, and it is having the only one variable, that is called as RN. Correct? Here we have two variables, and RN here we are going to initialize it to 0. Okay, and in this case also 3 events will occur, right? So first event is if an error-free packet with sequence number RN is received. Okay, so sequence number is equal to RN is received. Okay, what it should do, what the receiver should do, it should take that message in that particular packet and deliver it to the application layer, right? And then window will slide over to the RN plus 1 because it is the window size is 1. So it will slide to the next window. Then for that particular packet which is sent, he has to resend the acknowledgement number for RN. Okay. If an error-free packet with sequence number outside the window is received, that means it is not equal to RN. Okay. In that situation, packet is discarded. Okay. But acknowledgement number is equal to RN is sent. Okay. Third condition is whenever corrupted packet occurs, okay, the receiver will discard the packet. Fine. So this is how the FSM for Goback N Protocol is understood. Any doubt? Now there is the condition which we are trying to analyze, send window size. We always keep the send window size of the Goback N protocol. It should be less than 2 power n. Okay, then only we can expect the protocol to work in a proper manner. Because what happens is, if I make the window size is equal to 2 power m, okay, possibility of getting the erroneous packets, okay, is more. Fine. Say initially the window size I have fixed it to 3. Okay, so in this case I have fixed the window size is equal to 3. Okay, so but actually window size is now 4. Like, okay, window size of 3 against a window size of 4 we are talking. Say that 2 power less than 2 power m and is equal to 2 power m. Okay, so what we are doing is window size always you have to fix it the less than. For example, if I take m is equal to 4, okay, or m is equal to 2. Let me take m is equal to 2. So m is equal to 2 means 2 power m minus 1. 4 minus 1, it is 3, right? So what happens is the figure, it is giving you the comparison of a window size of 3, okay, against the 4. Fine, it is a comparison. If the size of the window is 3 means we are talking is less than 2 power m. Okay, so in that situation, all the 3 acknowledgements, if at all a condition we are seeing is all the 3 acknowledgements are lost. Okay, what happens? The timer, whatever we set by the sender will time out, correct? Okay, and it will resend all the 3 packets, agree, and it will restart the timer again, correct? So when it is resending, okay, so what happens is the receiver actually he has sent acknowledgement for all the 3. That means 0, 1, 2, all the 3 he has acknowledged. What is expecting? He is expecting the 3rd packet, but once he receives the same packet numbered with 0, okay, so what happens is he will correctly discard it, thinking that he has already received the 0th packet and he has acknowledged. Why he will take the duplicate copy? Correct, no? So he will correctly discard madadane correct ag madate receiver. Fine, but if at all the size becomes equal to 4, window size what we are talking is 4, okay, what happens is, see, always the window size, that is why we are telling it should be less than your 2 power m. Okay, say for example then 4 and the fix madkondini, if I'll fix it to 4, okay, what happens is what is the next packet he'll be expecting? Say for example 0, 1, 2, 3. Okay, for all the 4 packets 0, 1, 2, 3 he has sent an acknowledgement, correct, but it is not received. All the acknowledgements are not received by the sender. Sender has not received any acknowledgement, and timeout occurs. What happens when the timeout occurs? He will think that I have to resend all the 4 packets again, so he will send packet 0. Now what happens? What is receiver is expecting? He's expecting packet 0 only. Agree? Because the sequence number is 0, 1, 2, 3 for me. 0, 1, 2, 3 and the next sequence should start from 0 only. Correct, no? If you fix up the window size is equal to 2 power m, what happens? All the 4 packets you will send and all are not acknowledged. Correct? So what happens here? E sender row E0 packet na kalistane. That is first 0 packet because thinking that he has not received the acknowledgement. But what actually receiver is expecting? This next 0th packet he is expecting. But when the sender will send the 0th packet of first window, okay, first packet, fine, he will erroneously accept it. He will accept that particular packet. That means he'll think it as a new data itself. Agree? So in that situation, what happens? There might be a case where receiver is taking up and what you can say, he may accept erroneously some data which is of not a particular packet. Okay, so that case may occur. So what we have to do in case of Goback N protocol, we have to fix the window size. Okay, window size, it should be less than 2 power m, not equal to 2 power m. And receiver window, that is the sender window we are talking. Okay, sender window size, it has to be less than 2 power m, not equal to 2 power m, and receiver window always by default it is equal to 1. Correct? So this is about the Goback N protocol. The selective repeat we'll discuss in the next class. Selective repeat. So any doubt?